In this video, I'm going to show you how to use the quadratic plot program. It's in Chapter 6, and I come down and I press this button here. Afterwards, I go down to the description box, and this gives you all the information you need to work with the program. I'm going to be inputting data into the input values box. In this example, I'm looking at the relationship between confidence in one's math ability, which is my x variable that ranges from 1 to 15, with higher scores indicating that you have more confidence, and the outcome variable is your score on a math test that ranges from 0 to 40. The program assumes you've already done a quadratic regression analysis. It doesn't use raw data, but it assumes you've already done the regression. The first thing I do is enter in the low score on x, on confidence in math, and the high score, and then I enter an increment, which I'm going to set at 0.5. What that does is that's going to plot the predicted y-score at values of 1 through 15 in increments of 0.5. So it'll do it at 1, 1.5, 2, 2.5, and so on. The smaller you make this value, the more points you'll get. I need to enter in the regression equation here. And if I had covariates in the regression equation, I would have mean-centered them because it makes everything a lot smoother and simpler. So let's suppose in the quadratic analysis, my intercept was 1, that the regression coefficient associated with x was 3.30, and the coefficient value associated with x squared was minus 0.12. This option here tells you if you want to plot the points or if you want a smooth line. I'll go ahead and show it to you with the points. After I'm finished entering the information, I click Register Input. It then shows the syntax. I'm going to copy that to the clipboard. I'm going to start up R. At the beginning of R, I'm going to hit Control V to paste in the code, and it generates the plot accordingly. Now, one of the things it gives us before doing the plot, it gives you each x score, again in the 0.5 increments, and then the predicted mean of y at each one of those. And this is the plot of those scores. And you can see that the relationship is curvilinear, and it captures part of a quadratic curve. At low scores, his confidence in your ability goes up. Performance on the math test increases, but there's a ceiling effect, a place where it asymptotes, and at the very high end, the more confidence you have, it doesn't affect your performance. Okay, I recommend you take a look at the bivariate smoother program, which has some editing features and shows you how to copy and paste the graph to the clipboard and then use it for graphics programs. So I'll close this out. Come back up to the top, and that's it. Thanks a lot.